Hello, everyone. My name is Lale Başarır. Um, so we search for the intuition that exists within the design process and how it can be learned by artificial intelligence. That is currently gained through master-apprentice relationship and experience that builds up this knowledge. In the study, a way to enable users to attain an architectural design sketch while defining an architectural design problem with text is explored. This is an ongoing research, and it decomposes the components of the briefing and preliminary design sketching processes. The domain knowledge at each phase is considered for translating to constraints via natural language processing and machine learning models such as generative adversarial networks. And we suggest the construction of a representational framework to serve as a template for the definition of an architectural design problem. Um, the proposed framework takes the client's speech or textual description of the design problem, commonly known as the brief, and works on generating corresponding images that are depicting the visual versions of the attributes that are briefed. The proposed AI is expected to output architectural sketches involving spatial relationships. Um, so there's this word-to-vec method, and that is used to encode sentences upon translating sentences taken from the brief. And the brief is obtained from the client. And this is an 8-item brief. The text is translated into vector form for encoding. The words are then linked to a context within the network through adjustments by backpropagation. The context defined by the image corresponding to the textual description is then linked to the text by the GAN model. For generation of preliminary design sketches from textual and auxiliary expressions of intent, a two-stage ML model is proposed. Stage 1 starts with the embedding of the given textual description yielded through an encoder, a pre-trained encoder. Stage 1 generator network generates an image. Generated data looks like the training data in order to get the discriminator to believe that it is the real data. The discriminator outputs a value of either 1 or 0 to declare whether it classifies the image to be real or not. Although this process may look as if it's only a classification, it actually refines the generated images because it goes through those iterations. As the images are generated again and again, they are better versions of themselves. So this refinement improves the learning process. The framework proposed displays the inherently ill-defined quality of design briefing and does a scanning of available options of AI models to help refine the problem definition and solution suggestions. And in order to structure the intended model, where it is fed a brief and yields a preliminary design sketch, we need a data set with briefs and corresponding images. The work will continue with a problem specification language and a solution specification language with an iteration space in between. So we hope that this study motivates future research on refinement of design briefing stages with a deeper understanding of the problem space, and that initiates the design processes. So would this model correspond to the understanding of briefs as the client's intent? This framework is being constructed in order to understand the intuition buried in the expertise of the architect active during the preliminary design process. Automation of the briefing process can be possible. So the research starts with the transcription, as said before. The textual data is analyzed and set up the underlying semantic model representation. And the style transfer approach is used. The contribution of the research lies in the effort to uncover domain knowledge and structure the methodological and the intuitive steps that take place within the preliminary architectural design process. Thank you.